Today we're going to be covering how to solve square equations. So the first example is going to be our most basic one, where we're just going to isolate x. So the first thing I'm going to do is I need to find a way to isolate x. So in order to do that, I must figure out what the inverse operation of squaring a variable is. And in this case, we're going to have to take the square root of both sides. So the square root of x squared will just be x. The square root of 36 is 6, but I'm going to say it's a positive or a negative 6. And the reason why I'm including both is because I know 6 times 6 is 36. But I also know that a negative 6 times a negative 6 is also a positive 36. So notice both will work. Now for example number 2, it's almost identical to example number 1. However, they have an extra term here. This term is called a constant. So in order for it to look like number 1, I need to somehow get rid of the constant. And the way I do that is by doing the inverse operation. So if I read this, it would be x squared minus 13. So the inverse of subtracting 13 would be to add 13 to both sides. When I add it, a positive and a negative 13 becomes 0, so those are gone, leaving me with x squared equals, doing some side work, 36 plus 13, 6 plus 3 is 9, 3 plus 1 is 4. So it leaves me with x squared equals 49. Now this becomes a problem very similar to number 1. And again, in order to get rid of this squared, I'm going to have to do the inverse operation, which is to take the square root of both sides, leaving me with x equals positive or negative 7. So notice, when we take the square root of a number, there are two answers. There's the positive answer and the negative answer. So if you need to, refer to this example right here. Now we're going to increase the difficulty level just a little bit. Let's see what happens here. Now this is almost identical to number 2. So I'm going to go ahead and follow the same steps. I'm going to get rid of my constant by subtracting 50 from both sides. So negative 50 and positive 50 becomes 0, just leaving me with x squared equals, here, notice there's more negatives, so I'm going to go ahead and just mark it negative. Do some side work. 50 minus 2, I would borrow, and I'm going to say 10 minus 2 is 8, 4 minus nothing is 4, so this leaves me with negative 48. Now I'm going to take the square root of both sides. The square root of x squared is just x. Now here's where it comes a little bit tricky. So right now, if you're wondering what number could I multiply by itself to give me negative 48, you may find it very difficult. And the reason being is, here, if we even look up here in our first example, a positive times a positive gives me a positive number. So my answer is not going to be positive. And here, a negative times a negative answer is still a positive answer. So the question is it possible to multiply a number by itself and get a negative answer? The answer is no. So guess what? In this particular problem, my answer would be no solution, because there is no value for x that can make this equation true. So it's tricky, so you need to make sure, just remember, you cannot take the square root of a negative number. That's going to be very important to remember and to understand. Now, let's go to number 4. Number 4 is going to seem very tricky because there's a fraction, and automatically students look at fractions and think that the problem is going to be difficult. So if you look here, the first thing I would like you to do is read this to yourself. Okay, there's two ways you can read this. You can read it as x squared over 2, or in this case, what's going to be preferred is I would want you to read this as x squared divided by 2. Why would I want to do that? By reading it as such, you then realize what operation is occurring. You can say, right now, x squared is being divided by 2. So in order to get rid of the 2, I'm going to have to do the inverse operation. So the inverse operation of division is multiplication. So what I'm going to do is I'm going to multiply both sides by 2. I like to put it as 2 over 1. The reason being is I can see how they cross cancel each other out. So I'm going to go ahead and multiply the opposite side by 2. So in this case, it's going to leave me with x squared equals 64. And now it's, again, very similar to our very first example here. So what do I have to do? I'm just going to go ahead and take the square root of both sides. The square root of x squared is just x. And the square root of 64 would be positive and negative 8. And that's it. So it wasn't that bad. Now, let's look at number 5. Number 5 is going to be very similar to number 4, except it has a constant. So what must I do to get rid of that constant? I need to do the inverse. So here, we're adding 22, so the inverse would be to subtract 22. A positive 22 and negative 22 becomes 0, which leaves me with x squared divided by 3 equals, here there are more positives, and there's 3 more positives than negatives. It's going to leave me with 3. Now, again, it comes back to this fraction. So again, if you don't know what to do, read it out loud. What does this mean? It means x squared divided by 3. So in order to get rid of the 3, I'm going to have to do the inverse of division, which in this case is multiplication. So I'm going to put it as 3 over 1. And again, I like to do this to see how these values cross cancel. Let's not forget to multiply 3 to the other side, which is going to leave me with x squared equals 9. Be very careful. Some students often stop at this step, but there's still one more to go. You still need to isolate x, so I'm going to have to take the square root of both sides, which will leave me with x equals positive or negative 3. Now for our last example, which should be example number 6. Here, we're going to follow the same exact steps. I always want to get rid of the constant first, which in this case is the plus 22. And the way I would do that is by subtracting 22, because that's the inverse operation. Make sure I do it to both sides. Negative 22 and positive 22 becomes 0. It's going to leave me with negative 3x squared equals, here they're all negative, so I'm going to put negative here. I'm going to combine them, 125 and 22. 5 plus 2 is 7, 2 plus 2 is 4, 1 plus nothing is 1. So it's going to leave you with negative 147. Now, the next step is, how should I get rid of this negative 3? And again, if you are not sure, read it out loud. How would you read it to discover what operation is occurring? Since they're next to each other, it actually means to multiply. So this means negative 3 times x squared. So in order to get rid of the negative 3, I'm going to have to do the inverse of multiplying, which in this case is negative 3, divided by negative 3 to both sides. So at this point, the negatives are going to cancel each other out, and 3's are going to cancel each other out. Here, again, I like to mark that the negatives cancel each other out. So it's going to leave me with x squared equals, I'm going to have to do some side work here, 147 divided by 3. 3 goes into 1 0 times, 3 goes into 14, about 4 times, with the remainder of 2, bring down the 7, 3 goes into 27 9 times, perfectly. So I'm going to say x squared equals 49. Please make sure you don't stop prematurely. A lot of students like to stop at this step. We still need to isolate x, so I'm going to have to take the square root of both sides, which is going to leave me with x equals positive or negative 7. So that concludes our video. Thank you for watching, and I hope this helps you.